Okay, good afternoon. So, for those who watch our video streams from EU moms and so on, maybe watched this presentation already. Sorry, it's the same one. I didn't have any time to update it with something new interesting, but if you haven't seen that, I think you will find this interesting. So, the official name of the presentation is most underused and overused RouterOS features, but when my colleagues was checking my presentation, they said that I should really put an alternative name for this presentation, which is my holy war against Masquerade. And you will find out why just in a short moment of time. So, first you need to turn it on, and then it works. So, basically, objective is to help you to understand and diagnose most common RouterOS configuration issues, which come to the support at MikroTik.com. Also, to show you the proper application of RouterOS features and avoid configuration issues. Encourage you to use latest RouterOS versions and the newest features that comes out. And the most serious one is to reduce the amount of RouterOS configuration issue emails to support at MikroTik.com. So basically, if I have to put all the presentation in one slide, it will be this slide, because if you want to debug something in MikroTik, you have almost all the necessary tools already built in. So starting with tool profile, where you can see what CPU is doing, and you can do that for the whole CPU or for individual core. So if you see here in this list one core at 100%, you can actually go there, choose that core, and find out what it's doing, to find out where your problem is. Also, of course, you can sniff some traffic and look at the counters on the interfaces, and usually with all these indications, you will get at least some idea to find out what your problem is and to dig in even deeper into the next step and so on. So presentation plan is very simple. It will consist of the most popular configuration issues sent to our support. These examples are compressed, combined, and simplified for purpose of this presentation. And the presentation will show problematic configuration and correct configuration. Please don't confuse them. That's the whole point of this presentation. So let's go into the first one. So the short description of the problem, high layer 7 load. So if we take one of the best examples that's sent to the MikroTik support, you have 2 layers 7 protocol regexps that just taken from the internet, and then you add just 2 rules in firewall filter forward that just drops all the packets with those layer 7 filters, and this configuration is wrong. So let's go deeper into analyzing this. So client sees high CPU load, increased latency, packet loss, jitter, and YouTube and Facebook, it's not actually blocked. So you have a load, but you don't have an effect. If you take a look at tool profile, you see high layer 7 load. And the reason is very simple. Each connection is rechecked over and over again on every packet that's received, because your rules is based on the packets, not on connections. And layer 7, particularly these 2 patterns, are checked in the wrong place and against all the traffic. So just to understand how layer 7 works, let's go take a look at it. So it's method of searching for specific patterns in ICMP, TCP, and UDP streams. So on trigger, so when your rule captures a packet, next 10 packets or 2 kilobytes of this connection will be captured, saved, and searched for that pattern. So imagine on every packet that you receive, you collect next 10, and then again next 10, and again next 10, and then check it over and over again, which is useless, because all layer 7 patterns available on the internet are based on the beginning or on first 2 kilobytes of the connection, and that's it. If you capture the connection in the middle, you will not find that pattern, because it's based on the beginning of the connection in most cases, if not all. So how to correctly implement the same thing? First of all, you switch from using per packet rule, you switch to the connection. So you mark the connection, and with a simple log rule, you will easily see, just by checking out that pattern, you will see that pattern is based on actually DNS requests. It's not capturing Facebook or YouTube traffic, it's capturing DNS requests for Facebook or YouTube pattern, so there's no point trying to find that pattern in any other traffic than DNS traffic. So UDP, destination port 53, is the only possible protocol and port that can capture, that can have this layer 7 protocol pattern. So capture these connections but only based on these options. After that connection is marked, there's no need to remark it again. So there's option no mark, so previously unmarked connections only. That means that you will only do that once instead of all over and over again. And also, after you have connection marked, you just capture all the packets for that connection and then put a drop rule in forward and input. Forward in case you don't use your IP DNS cache, and input in case you use your own router's IP DNS cache. And this one actually works, just not for mobile devices, because they don't use DNS in the same way as the PC devices. So this set can block YouTube and Facebook of all PC devices without any issues, because they will not be able to resolve DNS for those. So that's example 1 that usually comes, so layer 7. Example number 2, queues doesn't work properly. So what we have setup with 2 local networks, so local 1 and local 2, 2/24 networks. In firewall, we just have FastTrack connection for all the traffic. And in simple queues, we have queues where we have max limit and destination specified. And this is wrong, and wrong on many levels. So let's analyze the problem. Queues work only when tooltorch is running. Strange. Or when I disable FastTrack connection rule. But when the queues are working, they will capture only download traffic. So, and also the traffic between local networks are limited, and you want it in the fast pathway. So what to do? How to diagnose the problem? So of course you take a look at the counters on queues, you take a look at the counters on FastTrack connection rule, and the reason for this problem is very simple. FastTrack rule is specified for all traffic, so, and simple queues target must be specified. So let's go into what is FastTrack. So FastTrack is actually a flag in connection tracking table that allow packets from that connection go through the router in fast pathway by skipping everything else, including queues. So if you FastTrack traffic, queues will not be able to see that traffic. So that's one of the main reasons why many complain that queues doesn't work. It's just because your packets go through the fast path and not through the queue. This FastTrack feature works only for IP version 4 TCP and UDP. And Sometimes some packets will still go through the firewall just because we need to update counters so that the connection doesn't time it out in connection tracking table, and so on. So sometimes you can see 1, 2 packets going through, but not the whole connection. And if we take a look at a simple queue target, target option is the only option that determines direction of the simple queue. You know, in simple queue you can specify upload and download, but it is upload and to what it is download. The only way how to specify it is by specifying target. So if you not specify target, target is actually 000/0. That means that all traffic is download for 000/0. So that's why nothing captures in upload. So the rule of the thumb is you always need to have target in simple queues. That's it. Or else they will not work, because destination option is only additional filter. It doesn't determine the direction of the queue. So the correct implementation will actually look like this. So what we did, we specify in and out interface, both local ones, in a FastTrack connection rule, and the opposite direction here. So this traffic from one local network to other local network will be actually fast-tracked, because we don't need to put queues on them. So they will skip all the queues. And we use target instead of destination in a simple queues. And now everything works. All the connections to the internet are limited properly. All the local connections going fast pathway without loading your CPU. So example number 3. High CPU load on my PPPoE server. So we have 3,000 PPPoE clients in /20 network, connected via 172.16 network to another PPPoE client with 3,000 clients in a different 10.x network. All the PPPoE servers and gateways are in the same backbone area, and redistributing connected routes like showing there. So this configuration is wrong. So let's take a look why. So problem is very simple. CPU is overloaded. PPPoE clients disconnect. Clients can't reach their target speeds. Sometimes can't connect to the device at all. And if we go to the tool profile, we see that routing process is hogging one CPU core. Sometimes all cores go to 100% with the PPP load or networking load. So the reason is very simple. OSPF is spammed with the PPPoE /32 route updates. So basically, as you know, all dynamic router protocol updates, precisely routing table updates, and protocol calculations in RouterOS version 6 are limited to the single core. So every time the PPPoE client connects or disconnects, it creates new /32 route or removes it. So and it initiates OSPF update in your network. So now imagine if you have 9,000 clients, how many connections and disconnections per second do you have on that kind of network? So every time it's just renewing OSPF all the time, over and over and over again. So, and the best thing about all this, you are actually running OSPF instance on every PPPoE client also, because you haven't disabled it. That means that if at least one of your clients know how to configure OSPF, they can tap into your OSPF. So to fix this, you need to know what the passive OSPF interfaces are and what stub areas are. So stub areas allow you to reduce the amount of routing information flowed into area. So basically all the external routes will just be reduced to the default route. And you can use area range to aggregate all the routes that are going out of the stub area into, let's say, single or several routes, so that only one advertised route go out. So for example, if you use /32 PPPoE, you can aggregate that into one, that's /20 for this example. And there is a way to set a passive interface flag on the interfaces that will exclude interfaces from OSPF protocol communications. And you can do that easily by these commands. So just create another area, type stub, add network to that area, add rearrange. This is aggregation, that all routes that will be in this network will be aggregated under this route. And set all the interfaces to passive. So additionally to your interfaces that you already have here that are part of OSPF, if you add this line in the end, every dynamic interface that will come up will automatically be passive. So OSPF will not run on it. So this should solve your OSPF problems. So let's go to the next problem, which is strangely similar to the previous one. So high CPU load on PPPoE server, but this time we have much more simpler configuration. Again, we have 3000 PPPoE clients, /20 network, we have static public IP address, we have Masquerade rule and no other firewall, and this is wrong. So what can be wrong here? It's like simplest configuration ever. Well, let's take a look at the problem. CPU is overloaded, so clients disconnect, clients can't reach the target speeds, sometimes clients can't connect to board at all. And if we go to tool profile, we see that firewall is dominating CPU load, and the reason is very simple, improper use of Masquerade. So, what is Masquerade? Masquerade is actually a unique subversion of Action Source NAT, and it was designed to use in specific situation when your public IP address can randomly change. So the IP address is dynamic, or in one or interface is dynamic, like PPPoE or something like that. So how the Masquerade actually works, every time an interface disconnects, any interface on the router board, or IP addresses on the interfaces changes, also again, any IP address changes, router will search and purge connection tracking from all old connections that were related to this interface that just disappeared or changed IP, and that's done to improve the recovery time. Now imagine you have 3000 PPPoE clients, dynamic ones, that go up and down all the time. So router have to go through and purge all those connections every time at least one of the clients disconnect or reconnect. So, and that's why I really don't like when everyone just use a Masquerade, just because they are too lazy to specify 2 address option in SourceNet. Yeah, there's actually price to pay for this guy. So if your public IP addresses are static, use SourceNet and use Masquerade only on this specific dynamic situations when your public is dynamic address. So correct implementation is just take and write the public IP here and use action SourceNet. That's it. Problem solved. So next problem is quite interesting. Local IPs leaking to the public network. So usually, mostly it happens in the case when you have multi-gateway device and policy routing and some kind of failover. You have static public IP addresses on the public interface, and you have Masquerade rules on the public interface. So what is the problem? After failover happens, packets with the private IPs as a source addresses leak out to the public network. So, and probably your ISP calling you saying that you are going out with the private network IPs. You can check that easily with tool sniffer. And the reason is also simple. Again, improper use of Masquerade and insufficient amount of safeguards. So what actually happens here? Again, as we talked just now, before in previous example, on disconnect, all the connections that were related to that interface were purged from the connection tracking table. That means that next packet that comes from that connection into your connection tracking will have connection state new and will have to go to the net. It will be routed via alternative route and will be NATed through your alternative gateway. But as soon as your primary link comes back, routing is restored to your primary link. So all existing connections start to go through the primary link with the addresses, with the local addresses, because Masquerade was already done on that connection when packets were leaking, going through the second gateway. So basically, this is how it works. There's nothing wrong with it. That's simply the way the routing works with the NAT. So how can you solve that? First of all, of course, use action source NAT instead of Masquerade where it's possible. Second, drop connection state invalid packets in your firewall. Also, drop all the connection state new packets with connection NAT state, not destination NATed, that's coming from the public interface. So basically, if the returning packets is not destination NATed, that means that the sending packets were not properly source NATed. So, and the best solution is to have a backup black hole route with a bigger distance for each routing mark. That will ensure that all the connections will actually expire before jumping to the next to the other gateway, and you will not leak your private IP addresses to the public network. So, next problem, VRRP and routing problem. So, typical VRRP implementation, we have IP address on the physical interface, we have VRRP interface on that physical interface, and we have IP address on that virtual VRRP interface, and this configuration is wrong. So very, very, very popular setup to the support. So what is actually wrong? It's this thing over here. Problem, routing doesn't work properly, FastPass, FastTrack doesn't work, networking process have a high load. So if you diagnose and take a look at the routing table, you will see that you have two interfaces in the same identical subnet, and routing is actually choosing one of them to route the traffic. So if either one is a good interface, which have a driver, FastPass support, and so on, VRRP virtual interface doesn't have FastPass support, and actually was not designed to be routed through. So the solution for this is very simple. Follow the manual by the letter and use /32 on VRRP interfaces so that it doesn't take part in the routing process itself. So all the packets are routed through the either one, not your VRRP interface. So this is a very common issue. Next problem, DNS cache. So we have this setup here. We have typical IP DNS with allow remote requests yes and to the Google server. We have Masquerade. We have FastTrack connection. We have public IP on the internet interface, and no more firewall. So, and this is wrong. Problem, you have high CPU load, high amount of unknown traffic on the public interface. So, I will tell you the secret, there's no such thing as unknown traffic in MikroTik. You should use tool torch or tool torch or tool profile, or even tool sniffer. You can find out exactly what the traffic is. And basically, in this case, when the profiles show also DNS load. Your router probably is used as Open DNS resolver. It answers recursive requests for hosts outside its domain, and it's utilized for DNS amplification attacks. Just because you didn't have firewall to protect your router as soon as you enable DNS cache. So if you enable DNS cache, you must place proper rules to protect .dns cache from the public interface and so on. By default, MikroTiks come with the firewall configuration like that. But if you do your own configuration, please make sure. I actually have the reject here because my testing showed that those sniffing attempts from China to find open DNSs and faster if you have proper reject. If you just drop it, they will try and try and try again. But if they receive the proper answer that no DNS here, then they will not try anymore for some time, for longer time. So, and of course, it's not only DNS, yeah, you should have a proper firewall whatsoever. So, but this is just to imply the DNS issue. So, next one, also very popular lately. My IPsec tunnel doesn't work. So, typical setup, 2 offices. You have one office, second office, IPsec tunnel in between. Simple Masquerade rule on both routers, which is again wrong. So the problem is IP security packets are rejected, tunnel cannot be established, and if you take a look at this tool sniffer, you will see that your Masquerade rule is actually changing source address for encrypted packets, so that source address doesn't correspond to IPsec policy on the opposite end, and the packets are discarded. So what to do? One option, the old way how to do it, is actually create an accept rule before the Masquerade rule. But I am here to offer you an alternative from the newest version. We added IP for firewall raw rules. So raw table. The firewall raw table allows you to selectively bypass or drop packets before the connection tracking gets to them. So this way you can reduce your CPU load significantly, especially in a DOS attack case or such. But in this case, if you skip the traffic from the connection tracking table, that means that that traffic will not be defragmented, because connection tracking need to defragment everything to look at the packet. Also, NAT will be skipped for all the traffics that bypass connection tracking, because NAT is heavily dependent on connection tracking. And there will be some other matchers like FastTrack connection or MARC connection or layer 7 that will not work with the traffic that bypasses connection tracking. And all that traffic that bypasses connection tracking will be connection state untracked. So if you add these 2 rules, so both directions to your raw, it will not only make your IPsec tunnel to work, but it will also will reduce the CPU load caused by this, because this traffic will just go through your tunnel. It will not go through connection tracking. So your offices will be able to communicate much more faster. Next problem. How to securely bridge 2 local networks. So the typical solution that we receive on our support is that people running L2TP tunnel, and in it run Ethernet over IP, and then bridge Ethernet over IP on both ends, this way creating local network. Well, that's wrong in modern days. So why? The problem description is very simple. Web pages open very slowly, slow download speeds, and strange suspicion that your competition knows your secrets. If you can diagnose that with tool bandwidth test, tool ping, use different sizes, uncheck the fragmentation, and you see what is the size of the packet that passes through the tunnel without fragmentation. And the reason is very simple. PPTP and L2TP is not secure anymore. It actually takes minutes for that traffic to be decrypted in modern hardware. Also, when you're running 2 tunnels, you have severe packet overhead and fragmentation because of this reduced MTU. So modern way how to do it is just simply run Ethernet over IP tunnel between 2 and specify this one small option over here, IPsec secret. If you specify secret, MikroTik will automatically generate IPsec policy for you, and your Ethernet over IP tunnel will be encrypted with IPsec encryption. Just like that. No other configurations necessary. Default best solution for combining speed and security will be chosen, and your tunnel will be encrypted, especially because some of our hardware now comes with the IPsec hardware encryption acceleration. So, and in 6.39, we completely rewrote the hardware encryption acceleration driver for all the CCR devices, basically to solve out-of-order problem with encrypted traffic. Before we had issue that you send traffic in one order, when it encrypts the traffic, it goes out in completely different order, which causes mismatches in opposite ends, so the speed was reduced. And now in 6.39, when we have our own driver, we actually get these speed increases over here on the devices. So this is done without fragmentation. I had my previous presentation to tell you that fragmentation is root of all evil, after Masquerade, of course. So here you go, the increased numbers. So I hope I will encourage you to use latest RouterOS versions and so on. So, questions?
Are your slides available anywhere?
Yes, already for half a year. It's exactly the same presentation that was in MAM Europe, so it's online in YouTube and the presentation slides are there. And you can also compare what story I was telling there and how it changed to this one. So everything is in YouTube, so everything is recorded, so you can listen it over and over again. Yes?
Going into the firewall rules to bypass, said that the Masquerade rule didn't seem to it changed that source. You recommend changing that to a source now?
I always recommend to use SourceNode instead of Masquerade if your public IP addresses are static. So Masquerade, there's always unforeseen things can happen if you just do the Masquerade. And the worst case scenario when your guys just create a rule, action Masquerade, and that's it. So it masquerades to all directions, in all possible directions, and then the mail starts. I have a strange behavior. Of course you have, but so Masquerade should be used only for specific case when you have a dynamic public interface IP address that changes and you cannot do anything about it. That's it. In all the other cases, get rid of the Masquerade. So, any more questions?
Yes.
You talked about VPNs and things like that between different sites. What's your opinion on not MikroTik to MikroTik, but maybe PC to MikroTik? What would you recommend nowadays for the best VPN?
Currently, I would stick to the IP security stuff because SSTP and OpenVPN can still use some features that will be available in newer kernel. IPsec is already in the kernel, so it's well supported and so on. So you can also IPsec the GRE protocol, which is supported on many platforms. So you can use it like that.
Any plans to allow IPsec to use domains instead of IP addresses for those of us that are stuck with dynamic addresses?
Don't we have such feature already?
If there is,
In
I
most
haven't seen it
cases,
yet.
we did the move to allow you to specify DNS names in most of the RouterOS configurations some time ago. I'm not entirely sure about that specific field, but if it's not, just write to us. We'll see what we can do.
Version 2, I don't know if it's supported now or will it be supported soon.
IKey version 2. So guys, who knows the answer for IKey version 2? Is it supported? So the answer is yes, it's there. It's one of the biggest projects in last 2 major releases, yes. 6.39 have, I think, the 99.9% completed, so we're actually now just fixing some bugs in some specific configurations. So, but it was added specifically because there was many requests.
Okay, any more questions?
Okay, thank you, I'm gone.
Thank you.